The product rule and the chain rule are both really helpful methods for finding the derivatives of more complex functions. But it can be kind of confusing when you have to use actually both of them in the same problem. But it can be pretty confusing when you have to actually use chain rule and product rule together to find the derivative of a single function. So in this video, I wanted to show you an example which actually came from one of my weekly live streams that I did recently, where we had to use the chain rule and the product rule together to find the derivative of just one single function, because it was a bit more of a complex function. And in our discussion of going through how to apply both the chain rule and product rule together, I'm gonna really lay out kind of the order you want to be thinking about things, because that's really kind of the key when you're having to apply multiple different derivative methods in the same problem, is thinking about what order you should be applying them. So we're gonna be going through that a bit in this video. By the end of the video, you should be feeling a lot better about these types of problems, because I know they can be quite challenging. So be sure to stick around to the end of the video. Without further ado, let's go ahead and jump into the example and I'll show you what I'm talking about. So another example here that we're going to have to use both the chain rule and the product rule in order to find the derivative of this function. So we're going to find the derivative of y equals x squared times the square root of 3x plus 5. This whole 3x plus 5 is inside the square root here. So just like I talked about in the last example, the first thing you want to think about is if we were to actually plug in some x value in for the x's here and actually evaluate what that output of this function would be for that x value, what would be the order of operations there? So basically we would first put our x in here and here. Okay. Based on order of operations, we would basically deal with this x squared first, and then we would deal with what's inside the square root here. Okay, and then the next thing we would do is to multiply, or I guess actually at that point, sorry, we would deal with the square root. So we would take the square root of this number that we got inside the parentheses here, and then the final thing, actually let me do this in the same order I did last time. So then we would deal with the square root, and then the final piece we would deal with would be to actually multiply these two things together. So again, I did first step in green, second step in orange, third step in red here, which is just this product. So just like I said before, think about doing these derivative problems when we're trying to take the derivative of all this stuff, when we think, you know, we may have to apply multiple different derivative rules or derivative tricks like product rule, chain rule, quotient rule. We want to go the opposite order that that order of operations, or PEMDAS, as you may have seen it, right? PEMDAS, which just says parentheses, exponents, multiplication, division, addition, subtraction. We're going to go basically figure out what PEMDAS tells us we would do, and then work our way from the last step within that to back to the first step within that. So the last step we would do, if we were just plugging in an x value into this and evaluating this function, the last thing we would do is this multiplication here, the multiplication of this, what's in this green circle here and what's in this orange circle here. That would be the final step. So as a result, since that's the final step for PEMDAS, that's going to have to be the first derivative trick we apply, because we want to work our way basically from outside to in. So just like the last example, that tells us what's in this, basically what's in this green circle here and this orange circle here are the two things that are being multiplied together in this case. So as a result, those two things that are being multiplied together is what you would make your f and your g. So we would need to make our f x squared, and we would need to make our g the square root of 3x plus 5. Okay, and then we can go through the product rule formula and process from there. So the product rule formula tells us that then once we find f and g, or once we decide what f and g are, you usually don't need to really do any finding to figure out what f and g are. You just have to decide one piece of the product is going to be f, one piece of the product is going to be g. Then we need to find f prime and g prime, the derivative of each of these two things. Okay, so finding the derivative of f, the derivative of x squared here, that's pretty straightforward. We can just do that with the power rule. We would bring the 2 down in front, keep our x as x, lower the power by 1 down to 1, which is just the same as 2x. Okay. Now we need to find the derivative of square root of 3x plus 5. And this is where the chain rule is now going to come into play. Because in order to find the derivative of the square root of 3x plus 5, we're going to have to think about an inside function and an outside function. So let's kind of, again, just like we did in the last example, we'll kind of make a separate side problem out of this over here. So let's think about finding the derivative of y equals the square root of 3x plus 5. So again, in this case, we basically have an inside function, which is going to be everything inside the square root here, and an outside function, which is the square root itself. So before we actually take the derivative of this, what I would recommend, and I recommend this really whenever you have to find the derivative of something with a square root, is instead of thinking of it as the square root of something, think of it as that thing, 3x plus 5, raised up to the 1/2 power. Because raising something to the 1/2 power is exactly the same as taking the square root. It's just two different notations to mean the exact same thing. So these two are equivalent. 3x plus 5 to the 1/2 and the square root of 3x plus 5 are the exact same thing. But the reason why this is nice is having a power, a 1/2 power, you can take the derivative of the, something raised up to the 1/2 power using the power rule, which is a little bit more convenient than thinking about a square root. The power rule is, pretty straightforward, about as straightforward of a derivative trick as it's going to get. So again, what we want to do is think of what's inside the parentheses here as our inside function. So 3x plus 5 is going to be our inside function, and then the 1/2 power is our outside function. So just like I talked about before, when you're doing chain rule, figure out first what your inside function is. That's usually going to be a little bit more obvious or a little bit easier to figure out. Once you figure that out, just imagine replacing that whole inside function with just x. So in this case, just imagine having x to the 1/2 power. Because what chain rule says is we are going to take the derivative of the outside function, leave the inside function alone, and then multiply that by the derivative of the inside function. Well, if we've figured out our outside function is just x to the 1/2, we can then just take the derivative of that outside function. So taking the derivative of just x to the 1/2, we're just going to use power rule. So we're just going to bring the 1/2 down in front. We're going to leave our x as x, and then we're going to lower the power by 1. 1/2 minus 1 is the same as 1/2 minus 2/2, which is the same as negative 1/2. So lowering our power by 1 just brings us to negative 1/2. So 1/2 x to the negative 1/2 is the derivative of x to the 1/2. So we've taken the derivative of our outside function. However, what we need to do is leave our inside function alone. So we're actually going to leave our inside function as 3x plus 5. We're going to leave that as 3x plus 5. We don't want to change it at all. So let me just move this over real quick. So we'll leave our inside function as 3x plus 5. Then we need to multiply this by the derivative of the inside function. Well, the derivative of 3x plus 5 is just going to be 3, because the derivative of 3x is 3, the derivative of 5 is 0. So basically we're just going to get the derivative of the outside function, leave the inside function alone, so leave our 3x plus 5 alone, take the derivative of our 1/2 power portion of that, which puts the 1/2 in front, lowers our power to negative 1/2, and then times by the derivative of the inside function, which is just 3. So this is then going to simplify the 3 and the 1/2 would simplify to 3/2 times 3x plus 5 to the negative 1/2. If we wanted to, we could then change this 3x plus 5 to the negative 1/2 back into a square root. And also, since it's now a negative 1/2 power, not only is it going to change to a square root, because 1/2 is the same as 1/2 power is the same as square root. Since it's a negative 1/2 power, it's going to be moved to the denominator. So this is actually the same as 3 over 2 times the square root of 3x plus 5. We could definitely change it back. We could leave it as this. Either way is going to be fine. But this is going to be the derivative of this function that we started with here, which is square root of 3x plus 5, which is exactly what this g is here. So what that tells us is g prime here is going to be this. basically what we kind of did here, you know, these problems where you have to combine chain rule, product rule, maybe quotient rule, whatever the case is. In this case, we're doing chain rule and product rule, obviously, but the concept is the same, even if you have a quotient rule mixed in there too. What you're basically doing is like creating a sub problem within your problem. So like, you know, we started with product rule. Well, doing product rule first, in order to find the derivative of one of these pieces, that is where chain rule comes into play. So then we kind of make this sub problem of applying chain rule just to figure out what that G prime is. Now that we've figured out what that G prime is, now we can ignore chain rule and just go back to thinking about product rule, because we've kind of dealt with the part of taking a derivative that required the chain rule. So now we can just think about product rule. Product rule just says that we're going to cross multiply these across. So multiply f times g prime, multiply f prime times g, and then add those together. So basically all we have to do is multiply f times g prime. So x squared times all this is just going to give us 3x squared on the numerator over 2 root 3x plus 5 on the denominator. And so that's what we get from multiplying those across, and then we add whatever we get from multiplying this times this. So 2x times the square root of 3x plus 5. And now that's going to be the derivative of that original function.
Well, I hope you found that video helpful. If you think more tutorials like this would be really helpful to you as you try to learn calculus and go through the course that you're taking, go ahead and hit that subscribe button down below and that bell icon next to it too, because I have tons more videos like this and there's going to be plenty more coming out, so you definitely don't want to miss them. And if you want to keep learning about chain rule or product rule or other derivative tricks and methods, just go ahead and click on one of those videos over there. Thanks, and see you next time.